Hi, this is Mrs. Bustamante. Today we're going to talk about bonding types or the different types of bonds. The first type we know about is intramolecular bonds, and that's the attraction inside atoms themselves or inside a molecule themselves. This is what forms ionic or covalent or even metallic bonds. So remember back when we drew Lewis dots for, say, a chlorine forming a bond with another chlorine atom, right? And we show that these were sharing, and we oftentimes draw this with a single line bond. That's an example of an intra, and notice it's RA for intramolecular. Things that are happening within the molecule themselves. And the other type that we know of is intermolecular forces, and this is ER. These are bonds or attractions between atoms and covalently bonded molecules. These cause things like phase changes. They're interactions between um, two molecules that have bonded even within each other. So what do I mean by that? I mean that intermolecular forces, you can think of them like an international flight, right? Going from one country to another. Well, if we think of different atoms, they're separate entities, right? So maybe one atom of water will interact with another atom of water. That's what we're talking about when we talk about intermolecular forces, and that's really what we're going to talk about in this unit. However, they are relatively weak compared to those intramolecular forces that we talk a lot about first semester. They're not nearly as strong as any of those forces holding atoms together within a molecule itself. There are three types of intermolecular forces: dispersion or London forces, dipole-dipole forces, and hydrogen bonds. The first type we're going to talk about are London forces. You might also hear those called van der Waals or dispersion forces. They have lots of different names, but they're the weakest of the intermolecular forces. And these basically occur between all types of molecules. These even can happen a little bit between noble gases. And what it is just temporary. It's not permanent, not always there. Shifts in what we say the density of the electron cloud is. So what does that mean? We know that the electrons are in a cloud. We know that they move around a lot. Well, and we know that there's a nucleus. In all actuality, sometimes those electrons kind of group up on one side or another. And that makes part of it positive, part of the atom or molecule positive, and part of the atom or molecule slightly negative. And so we call this the dipole direction, and we draw it like this. It looks like an arrow, and then it has a cross on one end. So this cross part looks like the positive end. That's where we draw the positive part of the molecule, and it moves towards the more negative part of the molecule. And then when we have two molecules like that together, well, just like magnets, right? When there's a positive side and a negative side, they sort of interact and have an attraction a little bit to each other. We draw it with a dotted line. It's not super strong. Again, van der Waals, London forces, dispersion forces, the weakest of the intermolecular forces between those two different atoms. There's also dipole-dipole forces, and this is an attraction between polar molecules. So that means a molecule that has a positive part of it and a negative part of it. And molecules have permanent dipole-dipoles because they have permanent positive and negative regions. So if you look at this atom, this part is always negative, this part is always positive based on what it's bonded to. Here's hydrochloric acid, for example. The hydrogen is always positive, the chlorine is always negative, right? And the negative end of one polar molecule is going to attract to the positive end of another polar molecule. And the more polar, meaning the more difference between this positive and this negative in electronegativity, the more or the stronger we say that dipole force is, because they're just think about having like more magnets, more positives and more negatives to be attracted to each other. And the closer they are together, meaning in space, right, the stronger the dipole force they will have or the stronger attraction that they will have to each other. This doesn't always mean that it's necessarily stronger than dispersion forces that we just talked about, but typically when we're talking about them, we see them being a little bit stronger if they are more polar or closer together. And then the last type of intermolecular force is hydrogen bonds. And maybe this is the most common that we actually talk about in real life. This is a special dipole-dipole bond between hydrogen, a very electronegative atom, with at least one pair of electrons. So what does that mean? It's always going to involve hydrogen, and then it's typically a really electronegative atom like oxygen, fluorine, or nitrogen. This is the strongest of the intermolecular forces, but even still, it's only about 5% the strength of a covalent bond, just to give you some perspective. So what do hydrogen bonds cause? They typically cause increased boiling point, meaning you have to boil something at a higher temperature, and an increased viscosity. And viscosity is just like the stickiness of atoms, or how much atoms want to stick together or stay together, which makes sense when we're talking about it being the strongest of our intermolecular forces. It's the stickiest. It's going to hold molecules together the most. And this is why we see the high boiling point in water that we do, and the reason it forms a dome when, say, you try and put drops of water together. So you'll notice, right, here's my water molecule, oxygen, hydrogen, hydrogen, another water molecule, oxygen, hydrogen, hydrogen, oxygen, hydrogen, hydrogen, oxygen, hydrogen, hydrogen. And all of our intermolecular forces are just shown with little dots, you'll notice. That's because they're not really super strong or even sometimes permanent bond, but there is an attraction there. And water is always our probably most popular example of hydrogen bonds in real life, and it's really important as we talk about in biology class too.